All right, we're back. And we have our next problem kind of lays out our inputs and outputs, our terms, things like that. And so this one is really just a matter of learning to read what it means by f of n minus 1 or f of n plus 1 or f of n minus 2. And so if f of n equals 50, f of n is 50, what is the value of n? Well, n would be 3. Okay, that's the input for getting the output of 50. Okay, and then it says, what is the value of n minus 1? Okay, well, if n is 3 and then n minus 1 is 2, then the value of, or the answer of n minus 1 would be negative 10. Okay, the next one it says if f of n is negative 250, what is the value of n? So that would be 4. And then it says, what is the value of n plus 1? So the value of n plus 1 would be 1250. Okay, and then f of n equals negative 250. So we're back to negative 250, and it says, what is the value of n? So n would be, would be 4, and then the value of n minus 2, so we go back 2 spaces, 1, 2 is negative 10. That's it. Okay. Up next, we have the recursive and the explicit rule. And we were kind of introduced to the recursive and explicit rule up in this problem right here, right? So we have the explicit rule, it's going to be written something like this, and the recursive rule is written something like this. All right, so it starts off, and the recursive rule always has these two things in it. F of n equals f of n minus 1, and then it's going to get multiplied by something. This is the only thing that's going to change, and this is your common ratio. Okay, so remember common ratio, you can take the second term and you divide it by the first term. So we say 64 divided by 128. And in this case, this is going to end up being a fraction, and 64 divided by 128 is actually 1/2. I would also accept 0.5. And so you just multiply it by 0.5. That's your common ratio. That's it, the recursive rule, done. After that, we're going to look at our equation, and it's f of n equals, and then you have 2 spaces here. Okay? And we're going to look at this space right here is your very first term. So this is the first one. And that first one is 128. Okay? The second one is your common ratio. All right? And so that is going to be 0.5. And then this time, because we're using exponents, we have n minus 1. And that's it. Okay, up next, it says, which one of these is an exponential function? The way that you can tell it's an exponential function is by where the variable lies. Well, if the variable lies in the exponent, it's exponential. This variable does not lie as an exponent, so it is not exponential. The end. All right, consider the sequence, -1, 2, -4, 8. So what I'd like you guys to do is write out your sequence. Okay, and I'm just going to write it out vertically. If you don't like vertically, don't write it vertically. I'm just doing it vertically because I have more space to work with down here. And it says the common ratio is -1/2. So we can take the first one and find out the common ratio by dividing, or the second one, and we divide it by the first one. And of course, this gives you -2. So -2 is not -1/2, so it is not, that is not the common ratio. But look, it says in the next one, the common ratio is -2. That is true. We matched it up right there, right? And then it says the seventh term is -64. So you could come up with the formula, you could come up with the explicit or the recursive formula, but for this particular type of problem where it asks you a bunch of questions about the sequence, sometimes it's actually easier to just multiply out and get to that term. So it says the seventh term is -64. Well, let's get to that term. And so 8 times -2 is -16. -16 times 2 is +32. and then we get to negative 64. So I'm just counting out 1, 2, 3, 4, 5, 6, 7. The seventh term is negative 64. This is true. And then it says the seventh term is 16 times the third term. So I'm going to go back to the third term right here, just counting down 1, 2, 3. And I'm going to multiply that by 16 and see if that answer matches up. And that's the best way to test it in my mind. I say 16 times negative 4, and that's negative 64, and it says the seventh term, and we're talking about negative 64. Answer is true. The fourth term is greater than the fifth term, so I'm counting down 1, 2, 3, 4. The fourth term is greater than the fifth term. This is a positive number. This is a negative number. That is true. And the fifth term is negative 32. 1, 2, 3, 4, 5. That is false. All right. Next up, we have A, B, and the y-intercept, the asymptote, the domain, and range. Okay, so A and B, simply A, B, right there. 3, 4. Your y-intercept is wherever it's crossing the y-axis, and we actually give you that in the graph, and that's 0, 3. So the y-intercept always has a value of x of being 0. And the asymptote is the line that it doesn't touch. So we're approaching the x-axis, and the x-axis is always at y equals 0. I would also accept the x-axis in this case. Okay, if it's not on the x-axis, I wouldn't accept that. The domain is what can x be, and the range is what can y be. And so x, because it's anywhere on the range here, we could put in 5 and we'd get some number way off the graph, right? And so the domain can be all real numbers. The range, however, is a little different. You can't get a y value less than the x-axis. So our range is actually y is greater than 0. Has to be greater than 0. Can't even be 0. Okay? All right, up next, we have complete the table for each of the functions using the given domain. Then graph the function using the ordered pair. Okay. So for these problems, it really is easier to just get used to using your calculator as a function, okay? And I'll show you why in a second. So I have 8, and I have 1 divided by 4, and then I'm going to go with my exponent button, and then the first one I'm going to put in is negative 1. Okay, and that gives me 32. And the cool thing about the modern calculators that we use is that you can just reselect your problem and then re-put in the new input. All I've done is changed what the input value is. And so I'm going back up. I'm going to that 0. I'm going to put 1 in. It gives me 2. Keep going up. And then I put 2 in, and it gives me 0.5. Ooh, numbers are getting smaller and smaller. And then I put in 3, and it gives me 0.125. All right. And then I can go through and I can find my y-intercept. Because we have a 0 there, that is our y-intercept. And we were given the domain, so we are not going to connect the dots. So it should be negative 1, and then 32 is way off the graph up here somewhere. So we got negative 1, 32. And then we have 0, 8. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's 0, 8. And then I'm going to say 1, 2, over 1 up 2. I'm going to say 2.5, it's somewhere in there. And then negative 3, 1.25, or 0.125, I'm sorry. And so this one, technically, because they were giving us the domain, we shouldn't connect the dots, but I think the intention is that they're just trying to give us a head start on this one, because we also, I'm just going to have them connected. So, and if you disagree with me on that one, that we shouldn't connect them, let me know in the comments. That'd be great, because I do recognize that you're not supposed to connect these, but sometimes it's hard to tell what the math teacher's expectations are. Okay. All right, next up it says complete the table for each of the function, then graph the function using ordered pairs from the table. Okay, so for this particular one, it is asking for the y-intercept, so you know that you've got to have 0 as one of your answers. Okay, and so let's go 0, 1, 2, 3, 4, and that's, I think, a good use of your domain here. All right, because then we can also see it progress. So same type of thing in the last one. I'm just going to actually put in the +1 first, because it'll make our order of operations a little bit easier later on. So we're going to hit 1 plus, so I put that one in first, and then 4, and we're going to go up to our exponents. And this time, what I want you to do is, I want you to do that x plus 1 in your head. Okay, so 0 is 0 plus 1 is 1, and we hit, and so this is 5. And then we go back up to it, and then we say, well, I have 1 plus 1, so that's going to be 2. And then I have 17. And then I have 2 plus 1 is 3. And that's 65. And then I have, I'm just going to keep going on here. 4 is 257. Holy smokes, those numbers are getting big. And then I might change this last one. See how they're kind of getting smaller as they go towards the x equals 0? So that means my negative numbers are going to be smaller. So I want to go on the other side of it, and I want to see what happens here. So I have -1 plus 1 is going to be actually 0 here. And so I end up with 2. Okay, so we know what our y-intercept is now. So that's 0, 5. Our asymptote, let's see what our asymptote is after we graph it. So we have 0, 1, 2, 3, 4, 5. That bell is early. Okay. And so we have 0, 5, and then we have 117, which is off our graph. 265 is way off our graph, and that's why I went to -1, and that's going to get us to 2. Okay, and I know that our asymptote is at 1 because this actually shifts our graph up 1 from the axis. So I know that our asymptote is right here. Our asymptote is actually y is equal to 1. And then our domain is x is all reals. And then our range is y is greater than 1. So I appreciate you guys watching. Good luck on your tests. Oh wait, I should graph this. Sorry. I'm going to graph this. And we're going to go getting close to our asymptote. Remember the asymptote is I'm not touching any line. All right, that's it. Thank you for watching.